Okay, so this is a picture of what you were given in your problem. So this is your graph of f prime. So on the class yesterday, I told you then that this would be the f function. Notice that this is positive. The y value here is positive, and the slope of this line is positive. Notice from here to here, the y value is negative, and the value of the slope here is negative. Then all of this is also negative. You know, it's underneath the x-axis. The actual y values on this graph are negative. Because this is f prime, that means the values of f prime are negative. We can even be very specific here and say, okay, here, this ordered pair is negative 2, 0. Because this is f prime, that means f prime of negative 2 is 0. And if you look here on the f graph, f prime of negative 2 is 0. The slope is 0. Also, it's 0 here at 2. It's 0 right there. The value at 0 is negative 2. And if you look, the slope right here looks like it is about negative 2. Okay, so the slope of this line is negative 2 at 0. If we made a tangent line, it would have a slope of negative 2 right there. Also, over here, it has a slope of negative 2. And right there, if you extended that line on, if you made a tangent line, it would have a slope of negative 2. If we find a 1, looks like right about there, it has a slope of negative 1. So if I go to that x value, right there, that looks like it has a slope of about negative 1. I can't find a place that has a slope of positive 1 here because there's no y values that are positive 1, and there's nowhere here that has a slope of positive 1. Until I come over here, right there, that y value, it looks like f prime of negative 3 is equal to 1, and so that means the slope at negative 3 is equal to 1. If we made a tangent line, that's exactly what it would look like. Okay, so now let's talk about concavity. The slope of this is negative, which means the second derivative is negative. So that's why this is concave down. This slope is positive. This is the slope of the slope. We're looking at the slope of the f prime function. So because this is increasing from there to there, the second derivative is positive, which is why this is concave up. Concave up is when you have a positive second derivative. Then this is concave down, and that's where we have a negative second derivative. The slope of the slope is negative. The first derivative changes from 0 to negative 2. So it goes from a slope of 0 to a slope of negative 2, and that's what makes it concave down. This is concave up because it goes from a slope of negative 2 to 0. So if you go from steep downhill to flat, it has to curve that way. So that's why that's the way that is. So hopefully that helps you understand the meanings of these graphs, you know, the meaning of the first derivative and the second derivative.